2b again. Note on the question. A full wave rectifier uses 2 diodes. Hope you people are able to see the screen, right? Yes, ma?
Yes, ma'am.
Okay. Note on the question. A full wave rectifier uses 2 diodes having internal resistance of 10 ohms each. In the sense, here he is saying that RF1 is equal to 10 ohms and RF2 is also equal to 10 ohms. The transformer RMS secondary voltage from center to each end is 200 volts. Okay, so here if you just recall, we were using 2 diodes, right? 2 diodes we were using, and I told you that it is a center tap so that the voltage will be equally divided. So here he is saying here it is 200 and here also it will be 200 only. He is just mentioning to 1/2. Okay, so the transformer RMS secondary voltage from center to each end is 200 volts. Find IM, IDC, IRMS and VDC if the load is 800 ohms. In the sense, he is saying that this load, whatever load you have here, this is 800 ohms. Okay, so for this we need to find. So in order to find this, let us go back and write all the parameters which are given. So the given parameters are, let me take different pen today. The given parameters are what is that he has given? He has given RF1, which is equal to 10 ohms, right? RF1, RF2. Okay, he has given us 10 ohms. Okay, then he has given that the VRMS to one of the side of the secondary of the transformer, VRMS, he has given us 200 volts. Okay, so he can either give us like, see, just read the question. The transformer RMS secondary voltage from the center to each end is 200 volts. Either he can give like this, or he may give us the transformer RMS secondary voltage is 200 volts, 0 volts, 200 volts. Okay, that means that here it is 200 volts, here it is 0, here it is 200 volts. That's what he means to say. So the other way of giving is, this is the other way of giving the question. Okay, so anyway, here he has given VRMS as 200 volts. Then apart from that, what else he has given? He has given RL, load RL also he has given. He is saying that it is 800 ohms. For all these parameters, he is asking you to calculate IRMS, VRMS, IDC, VDC. All this he is asking you to calculate. Okay. So here he has given RMS value, so you need to get VM value. So you know that VRMS is equal to VM by √2 for a sinusoidal signal. Okay, I'm talking about sinusoidal signal. Okay, so VM by √2. So this will be equal to, this implies VM is equal to 200 √2. Okay, so that will be your VM value. Can anybody tell me what is the VM value? Are you understanding? Let me just give me the clarity whether you are following. Yes? Harshita?
Yes, ma'am.
Harshita? Harshita came. Okay, fine. I just want to mention one more thing. From today onwards, I will call out your names and take the attendance. Okay. It may be any time in between. Okay. And don't say that you had network issue, all that. But whenever I'm calling your names, I want all of you to answer. Okay. Because I'm facing quite difficulty in handling you people, because by the end of the class, most of the people, at least 7-8 people per day, will not leave the class. Okay, the reason behind that is they'll just on it and go. Okay, so anytime in this 45 to 50 minutes class, anytime I may take the attendance. Okay, whenever, based on my discussions, whenever I get time, I'll take attendance. Okay, and that time you have to answer. Okay, fine. So here VRMS value is given as 200 volts. So from that we can find Vm by root 2. That is nothing but Vm by root 2. So from this we can find Vm value. Vm value is 200 root 2. So what is 200 root 2? Can anybody has got the answer?
282.84.
282.8.
4.
Okay, fine. So I need to find IRMS. You know what is IRMS? IRMS is equal to Im by it is full wave rectifier. What is the IRMS for your full wave rectifier? Im by Im by root 2. Okay, so for full wave rectifier I told you how to remember also. So in the full wave rectifier it will be the RMS values, whatever IRMS or VRMS, whatever we are getting, will just get in terms of same as your sinusoidal signal. Okay, same as your sinusoidal signal will get here. Okay, so Im by root 2. So I don't know Im, but I know Vm. So we know that Im is nothing but Vm by here I'll just take RL plus RF1 because RS he has not given. So it means that he is there is like he didn't give anything related to the secondary transformer resistance. So we need not take. So Vm by RL plus RF1 root 2. Okay, anybody have doubt that why I have taken this RL plus RF1? Anybody has doubt here? Okay, fine. If anybody is getting doubt, please let me know. Okay, so IRMS is equal to Vm value we have got as 282.84 divided by RL he has given us 800 plus RF1 it is just 10 ohms root 2. Okay, so simplify this and tell me what is the RMS value. Anybody can got the answer here? IRMS value. Anybody has got IRMS value?
246.
0.246 ma?
Yes, ma'am.
Okay, 246. Or if you want to write it in milliamperes, it will be 246 milliamperes. Okay, anything is fine. So VRMS is Vm by root 2. What is that Vm? We have got 282.84 divided by root 2. You may ask me, ma'am, in the previous class, you took VRMS is equal to IRMS into RL. You can take the same, no problem. It will give you the same answer. Okay, no need to worry. Okay, you can either use VRMS is equal to IRMS into RL or directly Vm by root 2. Anything is fine. If you remember VRMS formula, you can use. Otherwise, you can directly do V is equal to IR formula. Okay, anything is fine. Anything is same only. Okay, so what is this value? VRMS VRMS is equal to Vm by how much, ma?
99.99.
I didn't get you.
199.99.
199.99 volts. Okay, fine. IDC is equal to 2 Im by pi. See, the formula in full wave rectifier IDC is 2 Im by pi. For half wave it is Im by pi. Here it is 2 Im by pi. So 2 Vm divided by Im in place of Im I am replacing Im with Vm into RL plus RF1 into pi. Just substitute the values. 2 into 282.84 divided by 800 plus 10 into pi. Pi is 3.14. So again calculate and tell me the answer. Everybody in the class, make sure that you carry your calci for my class. Harshita, can you answer me? Harshita, are you there, ma? Harshita?
Yes, ma'am.
Can
Yes,
you tell me
ma'am.
the answer, ma?
I'm calculating, ma'am.
Now calculate it. Anybody else in the class has calculated? Please let me know the answer.
2.193.
How much, ma?
2.193.
2.193.
Yes, ma'am.
Just check this again. Just check it again.
Ma'am, 0.224.
0.224 is correct. 0.224 is correct. Or 224 if you have got one more term also, like that milliamperes. Okay. Then VDC. VDC is either you can take IDC into RL or 2 VM by pi, whichever you feel comfortable. Okay, let me just take either you can take this formula or you can directly use IDC into RL. IDC into RL. Okay, anything is fine. So IDC is 224 milli in the sense 10 power minus 3 into RL. RL is 800. Okay, simplify and tell me. Karthik, where you have gone wrong, have you identified IDC?
Yes,
Okay. So what is your VDC value? 170? 179.2 volts. Okay, so this is what your VDC. For the same problem, you can add calculation of efficiency, calculation of gamma as well. Okay, efficiency is like PDC by PAC. PDC is IDC whole square into RL divided by IRMS whole square into RL. So this RL and this RL will get cancelled. I'll be left out with I square DC by I square RMS. So I just add this question. Okay. In the question they have just given IDC, IRMS, VDC and VRMS. No, there only you write efficiency and ripple factor, both will find for this. So IDC is how much? IDC is 224 milli, in the sense 224 into 10 power minus 3 whole square divided by IRMS. IRMS value how much you have got? 246 milli. So 246 into 10 power minus 3 whole square. Okay, so simplify this, you'll get us 224 by 246 whole square. So tell me the efficiency, how much is your efficiency? What is the efficiency? Anybody has got the answer here? You'll get around 0.80, something like that only you'll get. Just check. Because ideally what was that? 81.2% something we got. So here also you'll get around that only.
83.5.
83.5.
Yes.
83.5. We've got the 5%. Okay. So eta in percentage is 83.5%. Okay. So actually here we have just taken 224 milli. So 224 point something it will be there. No. So maybe because of that little variation. Okay. Fine. Here also gamma you find. Gamma is equal to under root of same 246 into 10 power minus 3 divided by 224 into 10 power minus 3 minus 1 whole square. This will get cancelled. I'll be left out with 246 point divided by 224 whole square minus 1. How much is the ripple factor?
0.31.
0.31.
31.
Okay, this is what the ripple factor. I don't know, you people only should tell me. Okay, fine. This is what the gamma. Okay, ideal case we had 0.448 or 40 something you had, right? 408 something like that. Okay, so it's almost near to that. Okay, fine.
Is this
What? Come again?
246 divided by 224 square?
Huh.
Then I think it's wrong, ma'am. I'll
That's
do
it.
it.
You just do it and tell me. I don't know. IRMS value you have got as 246 milli. So 246 milli. IDC you have got as 224 milli. So 224 milli. Milli is 10 power minus 3. So both will get cancelled. So 246 divided by 224 whole square minus 1. I do that, you'll get the gamma value here.
0.45.
0.45. That's what it is, almost the same. Okay, so this is all related to the this problem. Okay, next. Now I will give you the question. I am not going to do anything. You should only solve. Okay, fine. In that only one part I'll teach you. Okay, I'll give you time and you people can do, because here only one part is little different. Okay, fine. Note in the question. A full wave rectifier has a full wave rectifier has a load of 2 kilo ohm. The AC voltage applied to the diode is 200 volts, 0 volts, 200 volts. Assume ideal diode. Calculate VRMS, IRMS, IDC, VDC, efficiency, ripple factor, and ripple voltage. Apart from this ripple voltage, you can find everything else. Just try to do this. And here he is saying that it is the ideal diode, then there won't be any forward resistance of the diode at all. Okay, so since this is the ideal diode, you can directly take RF1 is equal to 0. So direct normal whatever equations we were using before, you can just use IM is equal to VM by RL. RF1, the forward resistance will be equal to 0 for an ideal diode. Okay, so can anybody tell me, let me just write the given parameters. So can anybody tell me what are the parameters that are given? RL 2 kilo ohms, then RL is 2 kilo ohms, then from this what information you'll get? What information you'll get there? Hmm? 200 volts, 0 volts, 200 volts. That's what it means. Okay. Fine. So what is this 200? See, if I want to calculate VM here, how will you calculate this VM here? What is the value he has given? 200 volts he has given. No, it is nothing but the RMS value, effective voltage he has given. Okay, so that effective voltage is nothing but VRMS. VRMS value he has given as 200. Okay. Any doubts you people have here? Please let me know. Anybody has any doubt here? Please let me know. Huh?
No.
So VRMS is 200 volts, which is nothing but VM by root 2. Okay, you should never ever forget. Okay, so if they've given like this, it means that he has given the effective value, RMS value. Okay, so VM by root 2. So you need to know what is VM. VM is equal to 200 root 2, same like in the previous case also we had 200 only. Okay, fine. 200 root 2 you have got as 282.84. 282.84. Okay, so you got a VM. Rest all you can calculate. You people calculate and tell me the answers. I'm not going to calculate anything here. I want direct answers. I'll give you time now. You people can do it.